So about coagulation, right? We have two solutions to be added. We have either you add acid or you add alkaline. So the original state of the molecule of the latex, okay, has a lot of negative on the outside, right? I'm sure you still remember that, hopefully. Okay, so all this negative actually protects the membrane, right? And they repel each other when there's another, another molecule comes nearby, and then they just they repel away, right? So that keeps them in liquid state all the time. So if you want it to be in solid state straight away, we will have to add acid. So when you add acid, or we say like vinegar here, for this case is vinegar. Okay, my question is this for all of you. Do you all remember what is the name of the ion in acid or in vinegar? Okay, this is the theory part. You study liao, then you know. You don't study, then don't know one. Okay, so what's the ion? What's the name? Emilia, I need the name. I don't want the charge. Later we talk about the charge, but I need the name of the ions. Still remember? No, but good try, people. No? Okay. Hydrogen ion, which is positively charged. Okay? At least we tried. Luckily, you try now, not SPM. Luckily. If SPM, you're like, let's guess. Okay, hydrogen ion, which is positively charged. Okay, so you have to know the charge and also the name of the ions. So positively charged ion added into this, you will actually neutralize all of them, then no protection. Collision happens, then they break. That's why they coagulate. The molecule actually combine together with another one. Okay, so yeah, remember that. So when you add alkaline, okay, you are actually adding what ion? Do I expect you remember this or not? Do you? Oh, I've got something. Yes, which is hydroxide ion. Negative charge. Nice. Jingyu. This one I have to study one. You all have to go through a bit. You're like, where to study? There, intensive class, we got one chapter. I got notes for you also. And I got the exercise with you. We've been through like every chapters already, right? Look out for that. You should be able to find. Okay? So yeah, that's a little bit of background. But I'm not sure if this question requires that. This is section A, which is all the technical stuff. Okay, first one observation. Please write down what you see. Remember that? We've been trying this for quite a lot of times already. So you have to write down both diagram 1 and diagram 2 for both of what you see. So I'll let you all try. If you want me to check your answer, you can type to me and I can do some correction with you. But I'm gonna leave it to you now. Try out and write what you see. And remember, write for both, because it is not stated like diagram 1 or diagram 2. So when it's not stated, please write all. Okay? You try. Diagram 1, latex coagulate, or diagram 2? Okay, Emilia. Latex does not coagulate. Okay, that's good, but I suggest that the second half you change to, because to us, I understand most of us will say, oh, diagram 2, the latex in diagram 2 does not coagulate, right? But a more accurate answer will be, it actually remains in liquid form. So better we say oh, diagram 2 remain in liquid form, liquid state. So that's a better answering technique, or better answers for it. Because if your paper is marked by a strict teacher, then she might pick this part, you're like, no good. The second half, no good. I don't give you mark, it really depends. So I suggest let's be specific, then that will be good. Okay. Sean, so second half, you need another, that's the first one, you need another one. When vinegar is added, the latex coagulate in diagram 1. When ammonia solution is added, it remains liquid diagram. Yes, good, Nicholas Neo. Can I write remain the same for remain in liquid form? Okay, remain the same also not encouraged. Remain the same is like not saying anything, not encouraged, like stay the same, no changes, remain the same. Usually these kind of observations are inaccurate, or I should say, because you don't know what to write already sometimes. So we usually don't do that. Okay, yeah. Yeah, so I would suggest, because now we are actually, I want to push you to like better answering wordings or better answering techniques. So you got to change from those common answers, then you change to a better way of answering. Sean, the second half, you add on, what's this one? You did diagram 1 already. You want to try diagram 2? Okay, well, the rest you okay liao, then you go on with B, which is inference, means like reason. Remember your technique was what? Observation, you have to write down one time, and then plus reason. So you'll write down your observation first, but I think this is an error, not 4.1, I think diagram 1. Okay, so you just have to focus on diagram 1. You have to focus on this one. Then can liao. Don't have to write diagram 2, just do diagram 1. So like what? Latex in diagram 1 coagulate because, okay, this is a bit theory. If you say because vinegar can coagulate the latex, that's not going to give you any mark, because that's basically saying what is already stated here. That is equivalent to my mommy is a female, my daddy is a male, it's equals to not saying any answer. So this is when this come into picture. Reason, why? Why add vinegar then coagulate? Then you say, oh, because vinegar can coagulate. Duh, duh, I also know my mother is a female lah. So this is when your knowledge needs to come in, other than techniques. So, like this one, this one. Teacher, if cannot write no changes, what should I write? Oh, you mean the previous one, Iman? This one? You should say remain in liquid form, remain in liquid state. Okay, remain in liquid state. Alrighty. Okay, so you're okay with inference? Okay, of course, your observation, you'll write the same thing lah. Latex coagulated in diagram 1 because, whichever way you start. Because what? Because vinegar, or you can write acid, contain hydrogen ion, okay, which can coagulate the latex. Hydrogen ion, and please talk about latex. Latex coagulate because the is neutralized by, did you miss out something, Amelia? Because the latex is neutralized by positive hydrogen ion. Okay, good. You add on, the latex membrane. Okay, can also. Without that is fine also. You can write because latex is neutralized by or you can write because the negative charges outside, negative charges neutralized by positive hydrogen ions. Then you add on from the vinegar. You add on, then nice liao, from the vinegar. Okay, everyone's like all of your grammar, your sentence structure different, so it doesn't matter. My main point here is why? Because vinegar got this one, then this one can coagulate latex, or this one can neutralize the negative membrane of latex. also acceptable. Okay, no problem. So sentence structure and arrangement wise doesn't matter. I don't really care about that. Make sure you mention what is needed. Okay, can we go to next page? Constant variable, things must be fixed or something must be fair between two experiments here. Very obvious. You're Form 5 already lah. Some of you all been doing this kind of exercise for so many times. You know you're not gonna write apparatus like the length of the glass rod. No, right? Or like the brand of the beaker. No, right? Okay, don't make mistakes like that, right? That's when people don't know what to answer, then they write that kind of answer, right? So it will be volume of latex. Volume of latex. Okay? Yeah, nice. Okay, responding. This is also something that I want to mention. A lot of people, right, would probably, because we know table, got table, you can copy the answer, right? But no table, then you'll be thinking, okay, how to say, the observation of the latex, wrong. The condition of the latex, wrong. Those are not specific answers. Okay? What really your observation is, coagulate or not. So there will be coagulation of latex. Okay? Coagulation of latex. Like that, baru cun ma. Okay, so those answers like volume, sorry. I mean the condition of the latex, observation of the latex. No, those are not obvious. I mean, those are not like specific answers. Okay, try to avoid that kind of answers because if your paper is marked by a strict teacher, then it'll be risky there. Okay, next one. Like this one we've been doing so many times. Okay, I'm not gonna say anything today. You gotta try yourself for so many weeks already. Every week confirm we got do one. You do first. Later, the little boy will come out and ask the annoying question already. Or you try first. Or you want to check with you, you can type to me lah. Acid is a substance that coagulates the latex. Jingyu, yes, can, no problem. Acid is a substance that can coagulate. Yes, Iman, no problem. This should be a very easy one, actually, I would say. Very straightforward. Okay, all of you all right? So your topic or your subject is acid, okay? So acid is not a process, right? It's like something or it's a solution. So acid is a solution, or acid is a substance that can coagulate the latex, okay? That can produce or that is able to coagulate the latex, or that can cause the latex to coagulate. Same, latex is a substance which is added to coagulate latex. Can also, no need the which is added also can actually. Nicholas, acid is any substance that increases the concentration of hydrogen ion when it dissolves in water. What? Rian, why did you Google the answer? No, I'm joking, but no, that's not your operational. You have to answer based on your responding variable though. Did you throw me with that answer? Operational definition, your responding is this one. What is acid? Acid is something that coagulates the latex. Imagine the 5-year-old kid come and ask you, what is acid? Answer me. Then you, okay, acid is a substance that increases the concentration of hydrogen ion when it dissolves in water. Then the 5-year-old kid will look at you like, I don't understand, right? So the easiest way is to show what you can, to show what he can see in an experiment, okay? Which is this one. Acid, which is what we have, vinegar, is something that can coagulate the latex. Okay, no problem. All right, that's your operational lah. So most of you got the similar answer lah. Doesn't matter, you know, how it works. I mean, your structure. Acid to throw at your face and burn. Okay, people, let's go to next one. So obviously this is a fermentation process. Because we have glucose, we have yeast. Okay, very similar to chapter 1 we did last week. You might be thinking, I thought this one we had last week. That is the nutrient factor. Remember? One is with glucose and yeast, and the other one is yeast and distilled water. That's definitely chapter 1 topic. Okay, and wherever you have equation here, so pretty sure this is under chapter 4 lah. So you're okay, you know what is the gas that is released, right, in fermentation? We just did last week, if I'm not mistaken. So equation is given as well. Sometimes might not. You might have to write on your own. Okay, make sure you memorize a bit. So glucose plus yeast, glucose arrow is equals to X plus carbon dioxide. X, which is what is asked in the question below. So like, what is your product? Yeast and glucose becomes what? Which is 2 acceptable answer. If suddenly in an exam, you cannot think of the cannot. Then you can go for the usual answer, which is alcohol, which is also acceptable. Okay, but I suggest you better write ethanol. If teacher, strict teacher sees that, like she might not give you mark. So ethanol is your product, but also you can write alcohol acceptable lah. Okay, next one. State 1 characteristics of X. Alcohol characteristics. Do you remember characteristics of alcohol? Do I have the notes? Chapter 4. Hopefully, no, this is not. Oh yeah, I have. Sweet smell. Emilia, did you mix up something? Sweet smell is ester. Alcohol not sweet at all. Alcohol is like to the nose. Ester, sweet smell. So no. Soluble in water can. Wait, let me check again. Yes, can. Soluble in water can. Yeah, volatile can. There. I highlighted 4 for you to remember. I mean, 3 short answers will do. So you choose. Okay. So like that, if you've asked me one memorize or not, don't memorize, then 1 mark, don't have. But if you memorize, don't come out also a bit the big check, right? So very difficult study like that one. So yeah, choose whichever you want. All right, next one. There's no English, but there's BM here. Tandakan pada unsur yang boleh didapati pada X. Apakah unsur? Nama unsur tu dalam Inggris, unsur tu apa? Unsur tu elemen. Okay. Dalam BM tu unsur. So element, apakah tu element? Element means basic ingredient. We have, remember this chapter, it's about carbon compound. So obvious, right? We have 3 basic elements. The very starting of the chapter, we learn about organic and inorganic, and we did talk about, we have 3 basic elements, which is COH, which is carbon, oxygen, hydrogen. Okay, you understand? So there's no other choice here for you to choose but to choose carbon. Okay, can, no problem. Yeah, still have the other 2 more just in case. COH, carbon, oxygen, and hydrogen. Okey, namakan satu bahan yang boleh menggantikan larutan glukosa dalam raja satu. Okey, that means replacement for glucose. Do you remember the two juices we have? Two juices we have. Anybody? We have the juice pineapple. Yes, juice pineapple. Ada lagi apa? Orange juice. Amoy. Orange juice tu acidic. Tak boleh. Orange juice tak sesuai. Okay, kita kena guna jus-jus yang ada karbohidrat. Karbohidrat maksudnya kena buat kita ambil jus yang dari bahan yang tidak acidic. Sebab acidic tu bukan karbohidrat. So we have pineapple juice, we have sugarcane juice. Yes, correct. But do you remember the another choices of sugar? I'm gonna show you again. Where is it? Okay, there you go. Okay, don't go for citric. Okay, don't go for like lemon juice, orange juice. Those citric juice are very not good for the experiment. So we stick to this pineapple juice, sugarcane juice. Okay, yeah. And also, by the way, just to remind you, the replacement of glucose could be also maltose and sucrose, the brother. There's like three brother together. Okay, can. Right, next one. Yeah, question number 2, everybody. So synthetic rubber suddenly got a bit of chapter 7 because Cham one, this one chapter 7 and chapter 4 a bit related also rubber, right? So we have vulcanized rubber below, right? Okay, anyway, first question. Which is the largest percentage or major use of synthetic rubber? Your question is below. Okay, the largest or the major synthetic rubber, like very easy, the biggest percentage. Okay, the tire. Okay, like state 2 characteristic of synthetic rubber to make shoes sole. Theory lah, guys, theory. You got to spend time and sit down and read, you know. Where is it again? Okay. No, chapter 7. Chapter 7 here. Okay, synthetic rubber, guys. Okay, like shoe sole, it's under SPL, but anyway, what's the characteristics? You could use this, can be vulcanized easily, yes, or you can choose something else from this box. Doesn't matter, it works. Everything here works. Choose whichever two you like to. Okay. Okay, okay, next one we have okay, then back to vulcanized rubber. So I have to draw the structure here later, I guess, because there's a box. So with sulfur, do you remember the theory a bit? If you heat with sulfur, that's actually in your industry, like in factory, you can do that. But in science lab, we cannot heat with sulfur directly. You have to use it. You have to use another chemical to go through this process. Do you remember? Let me show you again. That's your chapter 4, right? Okay. If you want to do it in science lab, just in case question will ask sometimes, how about science lab? Science lab, do you remember this? Industry, you can heat with sulfur. Science lab cannot, because very dangerous. If we all heat with sulfur, right, the whole class will go to somewhere very far away. I will never come back anymore. Okay, so we have to soak in sulfur monochloride solution. It's a solution where it's a safer way, I would say. Then it turns into vulcanized as well. Okay, so just in case to remind you that, name the process to make vulcanized rubber. I'm pretty sure everyone knows this. Okay, of course, that is vulcanization. Okay, vulcanization. No problem. Okay, next one. Draw the structure. Okay, like very easy. We draw the wave also. Draw 3 wave lah. Usually I lazy one lah. So draw 3 wave is sufficient. Then remember the S linkages in between. No? So S, 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 S. And please label that is your sulfur atom. Okay. If I wrote latex in diagram 1, coagulate because hydrogen ion is added in the latex that can neutralize negative membrane for latex. Jajun, I suggest, okay, this is too long for 1 mark. Of course, there's no wrong writing more, but unnecessary to write so long lah. So if you want me to like pick the important points of the sentence that you sent me just now, I would say the most important thing is to talk about hydrogen ions or positive ion. So you see, I skip a lot, I was just say, latex in diagram 1 coagulate because vinegar contain hydrogen ion that can, I actually skip all the way to, that can coagulate latex. So my point here is hydrogen ion, coagulate latex, settle. So, I mean, writing a lot also correct, but that's just gonna waste a bit of time, and you might risk writing the wrong thing also. Like for example, the charges, you make like terbalik liao leh, or you write the wrong charges or you spell wrongly. That's more risk to me. So I would suggest that you guys write as short as possible. It's not essay, you don't have to like blah 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 a lot, just straightforward as possible. And you'll be surprised how teacher marking scheme sometimes is just one word. Or like just a very short sentence, or even just keyword. In marking scheme, there's no sentences one, I got to tell you. They look for like important keywords. And of course, your sentence must make sense. Basic English lah. Okay, to everyone, I mean, of course, to explain to everyone else. Okay, okay. Sorry, I missed out something. Exam need to label also. Okay, now another thing, Nicholas. The question didn't say draw and label, right? It might sound like, I think I draw then can now. Well, I would suggest in exam, all drawings must come with labeling. No matter they say draw and label or just draw the structure, I would always ask all of you to label what you are drawing. I mean, not everything. Like the main point here is to add sulfur atom, then sulfur atom can now. Okay, don't have to label everything else, just one then can now. Okay, can, no matter they say draw or label or not, do the same thing. Okay, okay, state the function of sulfur. Okay, theory long. You remember keyword or not? So what is the function of sulfur atom? So sulfur atom is actually to form cross linkages, right? Prevent polymer from sliding. Do you all have these key points? Those are what teacher looking for. Okay. So yeah, form your sentence. I bracket for you already. Important parts here. Deng 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 deng. Yeah. Okay, everybody. All right. So next one, number 3, what is this? Making soap. You all remember the process? Okay, you all know the name, you all know how to spell. The first 4 words are S-O-P-A. S-A-P-O, sapo. Can you all do it? Remember the whole thing? Please continue the rest. Sapo ni Yeah, I'm pretty sure you can. Okay, so coming from the background of palm oil, just to remind you, before the soap topic, right, it's about palm oil. So palm oil topic, we talk about fats. We talk about saturated fats and unsaturated fat. And then we go down to palm oil. And then after palm oil process, we bring palm oil to the next topic, which is to produce soap. So the ingredient, which is the next question is asking, what is the ingredient to make soap? Remember, it's always plant oil. It can be palm oil, it can be olive oil, it can be coconut oil, definitely plant oil. Remember that. But because your syllabus says like after the topic of palm oil, it goes straight into this. So we will use palm oil. Then hence X will be palm oil. Okay, and alkaline. Since we're talking about this, let me quickly show you the equation as well. Okay, so the method, saponification, so process of making soap, yeah. And the ingredient is this, everybody, or I should say your equation. So palm oil plus sodium hydroxide, which is alkaline. Your question didn't even give you the full equation sometimes. Okay, so palm oil plus sodium hydroxide, remember, arrow equals to soap plus glycerol. Okay, and let's see what the next question wants. Okay, blah, 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 name the part. Okay, you need to label the X and Y, Z and Y. Remember the head and the tail? There's a special name to it. Remember, soap molecule is the opposite of sperm. Sperm, the head go in first, the egg cell, then the tail stays outside one. But this is the balik. The tail reverse, belakang go in, and then the head stays outside. So outside means the water. So the head actually likes to be in water. The tail actually hates to be, or don't like to be in water. So water means hydro. Do you remember that? Phobic means phobia, right? Philic means they like it, philic. Hydrolysis, nothing to relate to this part, but since we're talking about this, rarely question will ask, but just to tell you, hydrolysis is actually another name of soap making process. Hydrolysis of alkali, okay? It's also a method. The name, other than we call saponification, right? It's also called hydrolysis. But no, don't use that. Don't use that. Rarely you need that, okay? I'm just going to tell you now. So the tail is the one that stays in the grease, means the tail hates water or doesn't like water. So hydrophobic is the tail. Is everyone okay? All right. So hydrophilic is the head, the one that stays in water. Can Okay, like D. Okay, you got to arrange the washing action or the sequence of how things or dirt or grease are washed away from the clothes or the fabric. So I would say the exam, right, purposely they give you like not complete one. You read, then you know you like, hey, what are they one? Purposely one. But you have to, based on your understanding, arrange them in correct order. Can you all try? But if you all don't remember, it's a bit difficult. It's from here, everybody. This one. Okay, so what's the sequence? First one, ladies and gentlemen. Not easy, because they purposely write weird sentences. P is the first one. You brush the clothes with soap. Means you apply apply on the clothes. Okay, and S. The head goes to the water. The tail goes to the grease. Then baru, the dirt is fully surrounded by the soap. Make sense? For Nicholas, actually, because you sent me PR as Q, right? So terbalik. And then lastly will be Q. So if you ask me, like memorize die the whole thing, this one. Yes, if essay come out with this question, good for you, right? But sometimes if subjective, they don't require you to write the whole thing, right? They just give you weird sentences and ask you to arrange. You must know your sequence properly in order to answer lah. So after they dissolve properly, then only the dirt is fully surrounded by molecule lah. Then only the soap leaves the clothes when you do the washing action. So a lot of sentences missing here, I got to tell you, but you must know the sequence yourself. Okay. Yay, we are done with chapter 5. No, chapter 4, I'm sorry. We're getting to chapter 5 a bit. Can we jump to where you find the first part, which is the engine? So you'll come with me. Which page? 88. Question 8 and page 88. Wow, what a nice number. 888. Fat. For Chinese, fat. 888. By the way, chapter 5 is a very important chapter. Every year, never fail. This chapter will come out. Okay? You'll be like, no, the one I hate the most. Yeah, unfortunately. Usually things that you hate the most, right, are the important things. So, righty, like engine, first, you all have to write down the name of the stroke. Reminder, please find out what engine is this. Baru, you continue. Okay, can you go for A and B1 as well, actually? B1, A and B1. Continue with B1 also, you all know. Okay, so done. Now, if you realize this is a sneaky question because the arrow is coming in from the right side. Because if you think about it, like, wait, I remember this is induction and then this is exhaust one, but they purposely the balik one. But still, stroke M is the first stroke induction stroke because this is induction inlet waft. I'm sorry. So inlet waft open, then no need thing now. Confirm is induction now. First one, okay, induction stroke, and then the last one. Okay, obviously, what else, right? What else is left? Which is exhaust law. Okay, now this is just one of the trick where they terbalik the inlet and exhaust. Sometimes they don't put them in arrangement some more. Jialat. That means they might not start with induction, they might start with power, and then you need to recognize picture properly. Okay, right, next one. What is L? Now, as I was saying, please remember what engine is this? This is diesel engine, hence L is, do you remember? Fuel injector. Okay, fuel injector. Yeah, it's not the spark plug. Spark plug is for the petrol engine. Emilia, what is plug? You mean plug, is it? Yeah, so it should be the petrol engine, remember? Okay, so for diesel, it's spark plug. Be aware. Then function of the diesel, function of the fuel injector. Now, fuel injector, right, only happens in third stroke, which is the power stroke, okay? Unlike the spark plug for petrol engine, it works already at the first stroke. It creates spark into the cylinder. But for diesel, right, the fuel injector is to actually inject the fuel, or I should say the diesel, but in the third stroke, which is power stroke. So for this one, you all just can make it simple. You all can write structure L, or you can actually straight away to inject or to pump diesel into, okay, to pump diesel into the cylinder. during power stroke. Okay, during power stroke. Okay, to inject or to pump diesel into power stroke. Into cylinder, sorry, during power stroke. Okay, C. Combustion take place. Combustion means what? Burning. Combustion means explosion, boom, burning. So burning happens during which stroke? Very easy lah, which is the third stroke lah, power stroke. Okay, first one is just to allow petrol and air mixture or air. In this case, will be diesel engine, will be just air. And then second one is compressor until very hot. The air compressed until very hot. Then the third stroke, boom, inject diesel. That's why power stroke, explosion happens. Then exhaust, okay? So next one. State one difference between diesel and petrol. Okay, diesel and petrol, the easiest answer will be the type of fuel lah. Of course, you can choose whichever you want from here. From here. Okay, no problem. Yeah, help yourself, everybody. Choose, like, you know how to form sentence on like four-stroke petrol engine uses petrol as fuel, while four-stroke diesel engine uses diesel as fuel. Okay, all good. Okay, I think we can go for one more calculation. I'll get into the take a timer, take a tape. Take a tape. I think we need to reverse all the way back to 75, everybody. Please reverse to 75. Okay, right. Now, just to remind you, ticker tape is always gonna be 50 hertz per, 50 hertz as a machine of 50 hertz. That means in 1 second, we can make 50 ticks. In 1 second, we make 50 ticks, all right? So remember all the numbering you should have, like 10 ticks, how many second, 5 ticks, how many second. We'll talk about that in a while. Now, question wants you to measure number 2 and write down the length. Definitely you can't do it because I think your page has been shrink. You don't get the correct answer. So we're just gonna do with a uniform increment. So every jump, so we have 3 here, obviously. But you measure, confirm not 3 one. Okay, can? Alrighty, so I think we have to write one more time here, sorry. Yeah, there you go, write on lines because your mark is here. Okay, I mean, you can write on the table, but that's fine. Okay, next one, draw the table. Okay, draw a bar chart. So that means that you don't have to draw the dot. A lot of people might be thinking, okay, I draw now, then I have to do the dot. No. That's when teacher asks you to cut the paper, you stick on graph paper, then baru look like that. Or else you draw a normal bar chart, stick together, by the way. Okay, so you draw accordingly. First one is 2. Okay, second one is 3. 4, 5. Oi. And remember, do the shading. Must shade. Yes, must do the shading for bar chart or histogram. Okay. And finally, strip 1, strip 2, strip 3, strip 4. Or section 1, section 2, section 3, section 4. Okay, can? Easy cheesy, right? Using your bar chart, state the movement made by the trolley. Actually, you all do a few times, then you'll know already. Same one, all the answer. Well, the graph is going up like that. What type of motion is that? We have only 4 types. It's either like getting faster, acceleration, or increase in velocity, or decrease, or we say deceleration. Or the other 2 types will be the dots are the same distance one, or same dot, those will be your constant velocity. But this is pretty obvious that the length is getting longer and it's going up. So definitely this is a acceleration. Acceleration, getting faster. Okay, if you're thinking, how you know? Then you look at this one. This is 1, 2, 3, 4, right? Means the paper is going this way because this is the section number 1. This is starting. From very close to very far apart means from slow to fast. Okay, from close to far apart, right? Means from slow to fast. Means acceleration. Okay, so then you can write the trolley is moving at acceleration. Okay, the trolley is moving at acceleration. Okay, no problem. Alrighty. Okay, section 5 of ticker tape follows section 4, also represents 1 second interval. Okay, I want you to predict the length of section 5. Okay, we don't have section 5, but if we have, then the length will be very easy, 6, because it's a acceleration, it's a steady increment. 2 to 3, 3 to 4, 4 to 5, and 6. So answer is 6. Okay, answer is 6. Yeah. Okay, there's no calculation asked here, but we can do it ourselves, which is, we have some space below. So I would like you to look out for acceleration answer. Do you remember all the calculation? So you need to find out acceleration, which is the final velocity minus the initial velocity over total time. Okay, do you want to try it yourself? Do you still remember how to do it? But I got to do some correction for you here. I think we don't follow this 1 second. Ignore the 1 second. Follow what we know. We know 1 second is equals to 50 ticks, right? Yeah, so ignore that. We have how many ticks per strip? We have 1, 2, 3, 4, 5 ticks. Each of them should have 5 ticks. So do you remember 5 ticks, how many seconds? Anybody? This one, you shouldn't be struggling during exam, you should key into your head already. 5 strip and 5 ticks and 10 ticks is fixed. Do you remember that? So 5 ticks is 0.1 second. Oopsie. The end. Oopsie. Okay, so 0.1 second for each strip is 0.1 second. Ignore the 1 second, it's okay for now. Right, let's, do you want to try? I think I show you, we do it together, okay? So in order to find out my final velocity and initial velocity, I've got to do it on the other side. So final velocity equals the distance over time, right? So final means the last strip. So the last strip is 5 cm over time is 0.1. That's why I say don't struggle already. It's 0.1 5 strip 5 ticks so that will be 50 cms negative 1. Okay, initial velocity is not enough space. Initial velocity is the first one, distance over time. The first one is 2 cm over 0.1 second. So that's equals to 20 cms negative 1. Okay, so once you've got your final 50, initial 20, bring it back, 50 minus 20 cms negative 1 over time. Now, I have 0.1 second per strip. Do you remember in acceleration, if you have 4 strips, 0.1 times 4 meh? Like all of them meh? Do you remember what I mean? So it will be 1 lesser, isn't it? So it should be 0.1 times 3. 3 strips, 1 lesser. Okay, because acceleration has to be 1 lesser. Remember, you have to go for interval. You have 4 strips, but we have only 3 intervals. So it should be times 3. Then your calculator will show you answer. So 30 over 0.3, that will be 100. CMS negative 2. 100 acceleration, CMS negative 2. Is that okay? Okay, if you all need time, you'll do a screenshot or something, a print screen. Yeah, that's actually how a full calculation will be. Okay, with the first part of chapter 5, we still have the rest, which we will continue next week. Okay, we call it a night, and I will see you guys next week. All right, bye-bye, people. Have a good night.